Hi everyone. Paper today. It's at 7 o'clock. It's not in this live, right? But it's gonna be. I think it's gonna be the June one, the June 2018. I'm pretty sure. Let me just double check. Yeah, June 2018. Obviously, paper one because that will be on Thursday. That will be at 7 o'clock. I've also uploaded today the video of my predicted paper. It's the edited one, so you can have a look at that as well. Okay, perfect. I'll see you later then. Alright guys, if anyone's got any questions that they want to go through, anything very specific that you want to ask, this is what this Q&A session is for, the drop in. This question here is one that someone wanted to go through. I'm just waiting for them to arrive and then we can have a look at that. But otherwise, if anyone else has any questions about anything else, particularly, obviously GCSE Maths, but ideally Edexcel, then just let me know and we can go through any topics, any questions. You might have a past paper question that you were unsure about. We can have a look at those. So just let me know in the chat what you would like to look at. Yeah, velocity time graph. Okay, let's have a look. Okay, so I think this is the one where you either have to find a gradient, so by drawing a tangent, or sometimes if they ask for distance, then you find the area under the graph. So it's just basically remembering to do that. So I'll show you an example. So something like this. So here we've got a velocity time graph of a car for 50 seconds, as you can see. Work out the average acceleration during the 50 seconds. Obviously give units for your answer as well. Basically, this is the one where you have to remember that we need to draw a tangent. So it's not just dividing, one number over the other. We need to have an actual, it's the tangent one, exactly. We need to have, because we're kind of looking for like a rate of change, isn't it? That can't only be at one single point. That has to be kind of over, a long time. So work out the average acceleration during the 50 seconds. So they've said for the whole thing, basically, haven't they? They've said for the whole thing. So the whole thing, I guess it's like if you were to draw a line joining up the start and the end, isn't it? But realistically, in this case, I guess you don't need to because you can see those exact coordinates. But yeah, the logic is the same. It's still that kind of tangent question. So finding the gradient of that, we want to do change in y over change in x. So obviously, I mean, subtracting 0 is going to make no difference, but just so I write it out fully, would be like this, wouldn't it, effectively? I guess you could just write 30 over 50 because the zeros don't make any difference, but just to show you that it is that change technically. we are using both coordinates. So obviously that is just 30 over 50, which would simplify to 3/5, which effectively is going to be 0.6. Now, in this one, they've asked for meters, well, they've asked for units, so you can either write it as meters, obviously, and then squared to the power of -2, or I guess that's the same as meters per... Oh. Is it? I don't know if the stream stopped there. It showed me something up next, so hopefully it didn't stop. But yeah, meters per second squared. You could write it like that, or this, whichever one. So yeah, if it's for the whole graph, then I guess you can just use those two coordinates. But let me grab an Edexcel example. This literal question here is just from Maths Genie, so it's not from a paper. But I'm just about to look at some that are. I don't know if it keeps if the stream keeps. I don't know if it's just replaying badly on mine, or if is it replaying badly for you guys as well. Just let me know if like the Wi-Fi is working or not. Because mine keeps reloading on when I'm watching it on my phone, but I don't know if that's the same for you guys, or if it's still carrying on as normal. So let me know if the stream is not working very well. It just keeps reloading on my phone, but it might just be my phone, right? So let me just get one from Edexcel for you, so you can see an actual past paper one. Where have I put it? Give me okay. Hopefully it's working all right, but you let me know in the chat if it's if the Wi-Fi's not very good, because for some reason it keeps reloading on my end. Okay. So an example from Edexcel. Okay, this is probably a good example. I quite like Edexcel because I feel like these questions are quite consistent as well. So I feel like you can recognize this one. I mean, the thing is though, this one isn't a velocity time graph, right? This is a distance time graph. But if you were asking about where you draw a tangent, it's going to be this one. I think I have also got an example of a speed time graph as well, but I'll show you a few examples for Edexcel. So for this one, the distance time graph shows information about part of a car journey. Use the graph to estimate the speed. So this is one where it says at time 5 seconds. So I know that obviously speed is distance divided by time, distance over time. So I think a lot of people think, oh, you just go at 5. What would that be across here? Where's my pen gone? That looks to be 2 squares up, doesn't it? Or would that be like 28? I guess just be careful of the scale. I'd say that would be probably about 28. Some people would just divide that as in 28 divided by 5. It's not that. This is also the one where you need to draw the tangent, okay? So obviously at that point, at 5, so now we have got an actual specific point. So let me get my line. So at 5, I'm going to just do my best here. Probably going to move it around a bit. You can obviously extend it as long as you want. I think I would probably put it, I don't know, maybe something like that, more or less. Obviously everyone's tangent will look a little bit different, but something like that. So you then pick 2 coordinates from that line. Now normally I just pick the one that they did say, so the 5 and the 28 is quite exact, isn't it? So I'm probably just going to pick that. So that was 5 across, 28 up, and then I'll pick one more. So my one happens to go through, the most kind of obvious coordinate would be 640. Yours obviously might go through slightly different, because obviously our tangents will be different. So they will have a slight range of answers, right? And then from here, we can just find the gradient. So change in y over change in x, remember which way around it goes. It doesn't matter which of these coordinates you put first, as long as you match them up for x and y. So I'm going to put the 40 first, so therefore underneath I'll put the 6 first for the x, if that makes sense. You could put it the other way around if you want to, but Okay, so then we work that out. What would that give me? Like 12 over 1. So I just got 12. And then in the answer they have given you the units. They said meters per second because that was the speed. Now the range, they said anything between 11 and 19. So that's quite a big range. Right, so I got kind of just on one end of it. You might have got the complete other end. You might have got something in the middle. That's fine. They will give you a range of possible answers because your tangent, you know, is never going to look identical to anyone else's. So that's 3 marks. There's one where it's a speed graph. So I guess that's more similar. Let me copy that one. This is also from Edexcel. Oh, this one's a little bit blurry. Hopefully you can still see it. So question 14, a car moves from rest. The graph gives information about the speed, v meters per second, of the car t seconds after it starts to move. Calculate an estimate of the gradient of the graph at t is 15. So that one's a bit more obvious because they've literally told you to work out the gradient, right? So that one we're going to obviously draw our tangent. It's actually telling us to work out the gradient. So that's quite good. So obviously at 15, I'm going to draw my straight line. Where's that here? 15. I like to read off, as I said, what the coordinates are before I start drawing a tangent. So there. I don't know what that would be. Looks like there's 10 squares between them, so each square would be half. So 2 squares would be... You can barely see that, can you? That's 15, 16, 17. That's probably about 18, I would say. 19, 20. Yeah, I'd go with that being 18. So then I'm going to draw my tangent at 15. So this one's kind of on top now. Okay, that was really bad. Let me move it around a bit. Obviously draw it with a pencil, right? Just in case you don't like your first version of it. Now let me pick it up. Maybe something like that, maybe a little bit more tilted. I mean, you know, just roughly. So I've got one set of coordinates, which I normally use the exact coordinates of that point that they've referenced. And then I'll choose another. This one looks quite exact here. Maybe not on the X, but this was a calculated one, so it doesn't matter if you've got decimals necessarily. Actually, I might go over here. That one's at 10, isn't it? And then across, what's that, 14? That's what I'm going to go with. 10 across, 14 up, and now I can create my gradient. So change in y, remember to put the y first, over change in x. What does that give me? 4/5? Oh, that's the equivalent of 0.8, isn't it? So I've got 0.8. Obviously, there's no units in that case because they've just asked for the gradient, right? So this is a 3-mark question, this tangent one. Obviously, don't rub out your tangent, leave it there. That's quite good. But then because this one mentioned calculate an estimate for the gradient, they haven't said what the gradient is, if that makes sense, what it represents. Now, this one, they did say anything between 0.6 and 1. So I'm like bang on right in the middle of that. So that's good. But as long as you get anything between those two ranges, that's fine. Then there was part B. Well, part II, I guess, which is then referencing to the fact that they didn't mention what the gradient represents. So in this case, they haven't told you what the gradient is. They've just said work out the gradient. Hopefully you can see that. There. Part II, describe what your answer to part I represents. They might do that. They might say work out this and you have to figure out that it means the gradient, or they might say work out the gradient and then you have to figure out what it means. So in the context of this graph, because this is now the speed time graph, isn't it? So for this one, it's the same as our first example. The main answer, right, is acceleration. That's like the main acceleration. Now they have obviously given a few options. You could say acceleration, you could say rate of change of speed, because obviously gradient is always a rate of change, but you'd have to relate it to whatever the context is, which in this case is speed, isn't it? Rate of change of the speed, which is the acceleration. You could say increase in speed over time, because I guess it has increased, doesn't it? But it's a change of speed. If you wrote just rate of change, that wouldn't be enough, because that would only be referencing what a gradient is. That wouldn't tell you what the context is, if you see what I mean. You can't just say the increase in speed. You'd have to say the increase in speed over time, right? Over time. So I think the easiest answer is to say acceleration, isn't it? That's kind of the easiest thing. They have said in the working out for part I, interestingly enough, if you put no tangent, I think they don't give you any marks. Yeah, I think you have to have drawn a tangent. Okay, so just sort of reading your question, Sean. To get the gradient, I just count how many steps it takes for the line to reach a certain point. You could always look at it as, I normally use coordinates, right? That's how I like to do it. If you've got this, visual graph in front of you, what you can do is, let's say, because let me go to the coordinates that I chose. I chose this coordinate here, didn't I? And obviously up to, where was it, 15. You could draw kind of like a triangle and just count that, if that's what you're meaning. So like you could do that and go, oh, okay, what's the difference? Well, it's starting at 14 going up to 18, so that's the difference of 4. And then across it's 5, so then it'd be 4/5. You could do that. That would, if that's what you mean, Sean, then yeah, that would be fine. The only reason why I like to use the coordinates is because sometimes, I don't know for your exams, Sean, but for our exams, obviously in this case you can see the graph, so you can count it, but sometimes they ask you to work out the gradient and you can't see the graph. They just give you like the coordinates. So in that case, you wouldn't be able to create a triangle because you wouldn't, unless you drew it yourself, but I wouldn't waste my time drawing it. So that's why I tend to use change in y over change in x. That formula, as in take away, both of them, work out the differences. Because then it's consistent for not just this, as in not just seeing the graph, but it's also a consistent method for if they don't give you the graph and you can just see, the coordinates, if they just give you the coordinates. So that's why I like to do it this way. You might want to count it and use a triangle like that. That's also fine. As long as you get the same answer and you've drawn a tangent, that's fine. The only other thing for this topic, I think, is the area under the graph, isn't it? Which is also quite easy. So, get you a different example. This one's just asking us to show what it means. It's going to let me paste it, that'd be good. Drag it, but it might be a bit small. Obviously, part A is work out an estimate for the gradient, right? Oh, that's really blurry. So we're not going to do that again because that's just what we've done, isn't it? That's the exact same thing. Same question. You can see it's quite a consistent question, which I quite like. Here's part B. You can actually see that. So part B, in this case, you've got a speed time graph. What does the area under the graph represent? They might ask you that. So when it's area under the graph, and you have to have a speed time graph. If you think about area, you would be multiplying, wouldn't you? If you were to work out the area, it's always multiplying. So think about speed times time. What is that? Well, that's distance. Just because they give you 2 lines of working out, or look, 2 lines of space to write a sentence, doesn't mean you have to write a sentence. You can just write one word if that's the answer. Distance or distance travelled, something like that. That's fine. Obviously, to find the area under the graph, you would just split it up. See if I can find one of those questions quickly, and then we'll do your question that you sent me, an email. Area under the graph. Now, I think with Edexcel, it's normally fairly obvious because they tend to tell you when they want the area under the graph. They tend to tell you to split it up. And I think that's kind of the key. Let me paste it, there we go. Yeah, we can have a look at histograms as well after this. So in this case, again, speed time graph. This is a speed time graph of a train. So work out an estimate for the distance the train travels. So you have to know distance when you've got a speed time graph is the area underneath in the first 20 seconds. But the key, I think, the clue is this bit here. Use 4 strips of equal width. Normally with Edexcel, it is 4 strips. So in that case, obviously, also don't forget that they've only gone up to 20, right? They haven't gone the whole way through the graph. So just double check where they've stopped on the graph. But it would split up normally quite nicely. So that's 20. Obviously 4 strips is every 5, isn't it? So that's the clue, is if they say 4 strips, they tend to say that. And then you know you're working out the area. Obviously it's an estimate, as I said, because it is a curve. We're not working out the literal curve, are we? That would be really difficult. So normally it splits into, maybe the first one might be a triangle. This first one here is obviously some kind of triangle, isn't it? If you were to draw a line like that, that's basically a triangle, isn't it? And then from there, normally you then have 3 different trapeziums. So you just, I mean, on your formula sheet, you do have the area of a trapezium there. So actually, you don't even need to remember that. It's on your formula sheet. So you see how I've kind of roughly created 3, a trapezium here, trapezium, trapezium, and a triangle. So then you just work out the area of each of those. Obviously use the coordinates for, you know, the base, the height, all of that kind of stuff. Work them all out and add them together. They're given 3 marks for that. So I think it's kind of those, from what I can see, it's kind of those 2 questions. Looking at Edexcel, most of them they say speed time graph. It's not, like, I've not really seen one where it says velocity, but I mean effectively same thing, right? So it looks like they'll either ask you to work out some kind of tangent gradient situation where it's an exact point, or they'll ask you to work out the area under the graph, or they might reference it as the distance, which is the same, the area under the graph, which is where they mention something about 4 equal strips. Normally they mention that. So it's knowing those 2, and then I would say just knowing what does the gradient represent. If they ask that, it's the acceleration. What does the area under the graph represent? It's the distance, isn't it? So they might ask you like what it represents as well. So from looking at my kind of past paper questions, I think that's kind of more or less what they would ask on this topic. Obviously at this point, this one they could ask, you know, is your answer an overestimate or an underestimate? I think that's pretty obvious. In this case it'd be an overestimate, because you see how we've kind of included slight bits above that line, haven't we? So it just depends. I think you could probably figure that out pretty easily. So yeah, I mean, I think that's pretty much that topic. I mean, you obviously know how to do area, so I'm not necessarily gonna go through that. Right, this question I was sent in to go through yesterday. Where is it here? Just let me know if you're still here if you want to go through this question, and I'll go through it, and then we can have a look at the next thing on the list. Just wait and see, because the person who sent it in to me obviously wants me to go through it, so I'm just making sure they're here. Otherwise I'll talk through it and then they will have missed it. If not, then we'll move on to the next thing and we can try back later. Doesn't look like they're here, so okay, I'll wait for them to come back. Alright, okay, the histogram ones with the percentages then. Yeah, I kind of, in my head I class that as like interpreting histograms. So let me grab some of those. Okay, so the one with percentages, yeah, I've seen that a few times, for sure. Let's have a look at this one. This one's a good example. It's going to let me paste it, as always. That would be great. because if I drag it, then it's kind of blurry, isn't it? Oh, yeah, no, that's horrible. Yeah, I'm going to go over the cone one. I'm just waiting for the person that sent it in to me to go through. I'm just waiting for them to reply, basically, because they are obviously the ones who asked to go through it. I'm trying to paste this so that, here we go. There's a histogram one. So I'm going to do this until they come back, and then we can look at the cone one. So obviously I don't want to go through it if they're not here. Okay, I think you mean something like this maybe. We've got a percentage down here, a 20%. I think a lot of the time it's 20% actually. But anyway, it doesn't really matter what the percentage is. There is a percentage. So the histogram gives information about the heights in meters of the trees in a park. As you can see, the histogram is incomplete. We're missing this bar here. So 20% of the trees in the park have a height between 10 meters and 12.5 meters. So that is this bit here, isn't it? So that is that bar that's missing. So that accounts for 20% of the whole histogram. None of the trees in the park have a height over 25 meters. That's just saying that there's no other bars. We've got all of them. So here is basically 80% of the histogram drawn, isn't it? So complete the histogram. So what I would do in this case is I would work out, I mean, given that they've actually given us the frequency density, sometimes they don't give you that, but they have. So I'd probably work out the frequencies of all of these 4 other bars. Obviously add them together, that would equal to 80%, wouldn't it? So it's kind of reverse percentages at the same time. So let me just check. This was a calculator one. Okay, so you can use your calculator. So normally for histograms, I like to use, we've got this formula triangle, frequency at the top, frequency density, class width at the bottom. I want to work out the frequencies, don't I? The number of trees. So obviously I want to multiply them. So for the first bar, just be careful of the scale, double check what the scale is. That looks like to be 1.2, doesn't it? 1.2 multiplied by 2.5. Now this is obviously, as I said, a calculator one. 1.2 times 2.5 is 3. So this one represents 3 trees, if that makes sense. So then the next one, we've got a frequency density of 2. And then the class width is also 2.5, because it's between, isn't it? Between 2.5 and 5. So what would that be? That'd be 5, wouldn't it? The next one, what's that? I think that's 2.8 times 5. Your class width is 5. So I think that would probably be 14. Yes, 14. And then the last one, we've got between, well, the frequency density 0.8, isn't it? First of all, and then what's that? That's 12.5 up to 25. So that's a difference, a class width of 12.5. 12.5 times 0.8 is 10. Okay, so if I add that up, that's 8, 22, 32. Is that 32? Obviously, if it's calculated, you might as well type it in just to double check. Yeah, 32. So what we're saying is the 20% is missing. So do you see how 32 represents 80% of the trees, or whatever it is, whatever the context is? 80%. So you've got 2 options here. You could either work out 100% and then find the difference, or probably what I would do, which I think is a bit more direct. I guess it depends on the numbers they give you. A bit more direct though. Move this up a bit, is I want to know how many is 20%. Well, how do I go from 80% to 20%? Well, this is the thing. So 40 would be the total frequency, right? 40 would be all of them. So then what's the difference? This bar here would be the difference. 40 would be 100%. So yeah, you could work out 100%. See, yeah, I've got 40. So then the difference you could see would be that bar. I'm just going to divide it by 4 just directly, because then that will give me 8. That's how I would do it. You could do it a different way. You could do 32 divided by the 0.8, because it's a calculator one, which gives you the 40, but then that's 100%, isn't it? So then 20% of that would be 8. You could do either of these methods, whichever kind of makes more sense to you, really. So either way, this bar here has to represent 8 trees. So now we've got our frequency, but obviously I need to put it back into frequency density. So again, my polygon, what's it called? My formula triangle Can't get the words right. My formula triangle, to find the frequency density, because I know the class width is obviously 2.5. I know the frequency is 8. So I'm missing the frequency density. So that would be 8 divided by 2.5. What does that give me? 3.2. So then I can just go, so that's frequency density, right? Frequency density. So then I would obviously then be able to draw it. Yeah, this is higher, yeah. So now I can just draw it. So 3.2 is 2 above, and then across there. So in this case, I would just use that triangle different times, you know. Trying to draw it straight, but obviously you'd be able to do a better job if you did it in real life. With a pencil and a ruler. There we go. That's what I would do. So then that would be completed. Yeah, we will go over the previous sector question. I'm just waiting for the person who they specifically requested it. So I'm obviously going to wait for them to say they're ready, and then we can go through it. That's one example of the percentages one. I want to just check another one, because this one was obviously a little bit easier because we did have the frequency density scale. Sometimes they don't give you that. So I just want to have a look at an example. Must have an example. Do I have an example? Because there's sometimes a scenario where if you don't have the frequency density scale, what you can do is just count the squares, like the literal squares. That makes sense. Oh no, all of the percentage ones do have frequency density. Oh, okay, well that's easier then. Yeah, I've got 3 examples with percentages. They're all 20%, so I don't know if specifically they're going to be all 20%. Do you want to go through another one, Mariana, or is that okay? I think it's just in the case of just using that formula triangle, basically. As long as you remember that, you can work out anything. That's all right? Okay, perfect. All right, well, we'll go through the sector one, seeing as everyone else wants to have a look at it as well anyway. Yeah, this was quite an interesting one, this one. Did find which one this was from. I think it was from the November one. A November paper, I think. Let me check. I think it was November 2022, maybe? Might be wrong. I'll find it again. Just so you know. I'll have a read through it. Because I think this was kind of a hard one, this one. Yeah, here it is. Oh no, November 2019, paper 3 this was. Just in case you were interested. Yeah. You see the whole thing? Let me move it down a bit. Okay, so this one we've got, the diagram shows a sector OACB, so this one here, I think it was meant to have, like the C I think is here, you just can't see it, of a circle with obviously centre O, so I guess that's O there, isn't it? The point C is the midpoint of the arc AB, yeah, so there. The diagram also shows a hollow cone with vertex O. The cone is formed by joining OA and OB, so they've used this sector. Imagine you had this sector and then you glued this side to this side. It would create a cone, wouldn't it? You see how O is now at the top? It would create a cone and A and B are joined. So the cone has a volume of 56.8 centimeters cubed and a height of 3.6 centimeters. Calculate the size of angle AOB of the sector. So they mean like inside, right? This side, inside the sector. Now, they've obviously given you 2 formulas, so if you weren't really sure what to do with this one, I would just kind of start with the formulas. Obviously, my first thing is to think of the because they've given me the volume, I'm going to start with the volume of the cone. So I'm going to just set that up. So that volume of the cone, they've said, is 1/3 pi r squared times by the height, which we do know is 3.6, equals, and now we know that it equals to 56.8. Now this, as I said, is calculator, right? So that's fine. So the radius is this bit, isn't it? Here, radius is that. We don't know the radius. So do you see how just by setting up that equation, really the only thing I could do, even if I didn't know what to do, the only thing I can do is just solve it to find the radius of the cone. I might as well do that, mightn't I? because they've given me the formula for some reason, haven't they? So I'm just going to rearrange this. What would I do? Let me grab my calculator so you can see. Calculator, 56.8. I would divide it by 3.6. You can divide it all in one go if you want, but I'm just going to go through it kind of step by step. That's divided by 3.6, divided by the 1/3, or in other words, times it by 3, and then divided by pi. So that answer is just the radius squared, right? I've moved everything across. Radius squared. They're kind of annoying numbers, but anyway. So what was it? 15.06666795, I think. I'm just writing all of it down for now. So, yeah. Okay, so that's the radius squared. You could obviously then square root it if you want to get the actual radius. So 3.88 ... 3.88. Obviously that carries on. Don't forget that, you know, we're not literally rounding it, but... Okay, so we've got the radius. Now, the only thing is, though, that's the radius of the cone, okay? You write that down. Cone radius. That's this bit here. That's not the radius of the sector. So I've used that. I've used this. You can kind of tick that off. They won't give you a formula if you don't need it, right? So tick that off. Then I'm thinking, well, what else have they given me? They've given me the curved surface area of the cone. Now, think about it. The curved surface area of the cone, in this context, in this question, technically is the same thing as equal to the area of the sector, isn't it? If you were to kind of lay it flat again, it would be a sector like this. So that's how they're going to link them. We can say, if we work out the curved surface area of the cone, we can then put that equal to the area of the sector. Now, the only thing, though, is, okay, obviously we've got pi, we've got the radius of the cone, but they want the length. Do you see how the length is not the height? It's this diagonal. So I think we also have to work that out. What I would do is, this is where I would bring in trigonometry or Pythagoras, or one of those. I guess Pythagoras in this case, because we don't have an angle, do we? If I draw a line there, I know this is a 3D shape, but just imagine that it's like just a 2D triangle. I know this base number, don't I? I know that that's the radius, 3.88, but I also know the vertical is the height, 3.6, and the one that I want to find out is the length. So yeah, in this case, we've actually just got Pythagoras, haven't we? Just think of it as a 2D triangle. Don't worry about it being a 3D shape. So we've got Pythagoras here. So before I work out the curved surface area of the cone, I need to know the length. So I'm going to use Pythagoras. Obviously, just label the sides. A and B have to be the two like vertical, horizontal sides, and C is the side that's the hypotenuse or the diagonal. So we've got 3.88 squared, which I'll probably just use this number back here, just to, you know, have all of the decimals, plus 3.6 squared equals the length squared. So obviously grab my calculator again. So I've still got the answer there, so I'm just going to square it again, plus 3.6 squared. So that's the length squared, but then obviously I want to square root that, don't I? So square root that. So the length is 5.294 ... The length is 5.294 ... Okay, so that's that one there. Now I can do the curved surface area, can't I? The surface area is, they said pi times the radius, which was 3.88, times the length, 5.294 ... There. Now obviously again, put that in my calculator. So this one, just take my answer. I'm going to do the square root of that just because I want to keep as many decimals as I can. So that's the 3.88 basically, isn't it? Times pi 64.557 ... Now I can forget about my cone, because as we said, we can make that link, can't we, between them. The curved surface area of the cone is equal to the actual area of the sector, isn't it? Because if you think about it, when you fold the sector together, it creates the curved surface area, so it's the same thing. So now I'm going to set up my equation, right, my equation for the area of a sector, which is not on your formula sheet, but the area of a circle is on your formula sheet. So it's basically that, isn't it? So the area of the sector, should know this, obviously the whole circle, pi r squared. Then to get just a small, section of the circle, you do the angle divided by 360. The reason why I want this formula as well is because I want to find out the angle. So I need a formula that has the angle in it, don't I? So I can then solve it. Let me scroll down a little bit. Now, obviously I'm going to sub in, the only thing I need to sub in is the radius, but just be really careful because the radius, let me highlight it, of my sector, this bit, or the other bit, or the AO or BO, isn't this bit here, is it? It's not 3.88. It's actually the length, isn't it? So we're going to use not 3.88, but we're going to use the length again, which was our 5.294. So just be really careful with that, because I think, because it obviously doesn't look to scale, it can be quite easy to think that the 3.88 is the radius, but it's not. So the area of my sector is pi times 5.294 ... squared times by the angle, you can put x if you want, you don't have to put theta necessarily, over 360, but then that equals 64, doesn't it? The 64 number, 64.557. Do you see how I can create this equation? And now the only thing that's missing is the angle. So I just need to rearrange this and solve for the angle now. So calculator again. I've still got my 64 number, sorry. Still got my 64 number there. So I'm just going to directly take it, divide it by, probably put this all in one actually, I guess. You could do it separately or put it in one. Pi times 5 point, I know 294 isn't, 294, I know that's not the whole thing. I know there was more decimals, but I don't have the answer recorded, so that's fine. We're pretty close, aren't we? Squared. So divide by that gives me 0.733 ... But then also I'd have to times by 360, wouldn't I? There we go. So that's my angle, 264.95. So theta, you can obviously write it in multiple steps. I've just done it in one. What was it? 200, said it. 263, yeah. 0.95. Now then at the final bit, this is the last bit, that's when I would round it. I try not to, if I can avoid it, I try not to round things until right at the end, just so my answer is the most accurate. 3 significant figures would obviously be 264. What's that? Degrees, isn't it? Degrees. Don't worry, Fatima, this is a drop-in session, so you can turn up at any point you want. You don't have to start, you don't have to turn up at the beginning. You don't have to turn up until halfway through. It's up to you. If you've got any questions, then it's just a drop-in session for that, basically. So there's the answer, and this was, how many marks was this? 5 marks, obviously. I think you could probably assume that, couldn't you? 5 marks. Okay, so that's what I would do with that one. I don't think it's kind of one that I think was kind of hard to maybe figure out what to do yourself, but what I did was, in order to help me figure out what to do, was I was like, okay, well, they've given me these equations for a reason, you know? Why isn't the radius solved by having that volume of the triangle and add What do you mean the volume of a triangle? A triangle is a 2D shape, so there is no volume of a triangle. Yeah, silly mistakes, that's quite hard. I don't know if silly mistakes is necessarily a case of revision, or it's more just practicing checking your own answers, I think, isn't it? Or practicing trying to go through the questions and not like racing through to the point where you might make silly mistakes. I think it's more that, isn't it, that you probably know what to do. You might have just written down maybe something slightly wrong or made a slight mistake, but it doesn't sound like that's necessarily revision thing. It's more practicing doing past paper questions and going through it not so slowly that you obviously can't finish the paper, but slowly enough that you are checking kind of each line. Does that make sense? Did I type it into my calculator correctly, or did I, just self-reviewing your work? I think that's the thing with silly mistakes. Sometimes I think it helps with there are some questions where you can kind of, like, for example, in this one, I know that my answer has to be obviously less than 360 degrees, but it's also going to be, I know it's not drawn to scale, but it's obviously not going to be like less than 180 either. It's going to be somewhere between 360 and 180. So for example, if you got an answer that was bigger than 360 or smaller than 180, you could probably look at it and go, does that make sense? And then go, no, do you know what? It doesn't actually make sense. And you could go back and go, I probably made a mistake somewhere. So sometimes I think once you've got an answer, just look at the answer and go, does that make sense for the context of the question? Some questions you just don't know. If it's just algebra, it could be any number, couldn't it, really? But with shapes particularly, you can get a gist for it. For example, Pythagoras, I know that the hypotenuse has to be bigger than the other two. So you see I got 5.2. That makes sense to me. Obviously, it's not going to be 25 because that wouldn't make sense, would it? It's going to be something close to 3, 4, 5. But it has to be bigger than these ones. So I can also look at that and go, well, it is, but it's just taking that little bit of extra time just to review your work and go, does that make sense? Have I read through line by line if you can, or if it's the fact that you do the whole paper, and if you do have maybe 5-10 minutes at the end, really spend that time kind of going through your own working out. I know it's boring, and I know at the end of the paper you just want to leave, but if you do have extra time, do use all the time they give you to review your answers and just double check everything. And because I know silly mistakes is so annoying, because you're like, oh, I knew what to do, but I wrote the wrong thing, or I just missed out this one thing. Because when I first did this question myself, I got like 400 degrees, and I was like, well, that doesn't make sense at all. I was like, I've definitely gone wrong somewhere, and I worked backwards and I found out where I went wrong, because I kind of just thought about it. Does that make sense? No, it doesn't. In this case, anyway. Sorry, so you said you meant the cone. Why isn't the radius solved by having the volume of the cone and add multiplied by something over 360? Because the cone is whole, isn't it? It's not a small section of the cone. The cone itself is a whole cone, if that makes sense. It's kind of 300 out of 300, isn't it, degrees? The cone is a complete cone. It's only the sector when it's made into a 2D shape that it's not complete. I don't know if that makes sense. Do they give surface area and volume formulas for shapes like cones? Yeah, okay, so as far as I'm aware, and I obviously speak mostly for Edexcel, right? I don't necessarily, if you're doing IGCSE, this might be different because I don't teach IGCSE, for example, but normal GCSE, and I know specifically I would mention for Edexcel and AQA, those are the ones that I do know about. You will get the formulas, as you can see on the actual question, for the surface area of anything that's not, well, not anything, no, let me reword that. You'll get the curved surface area of the cone. Do you see how that's just the curved bit? If they did ask you to work out the surface area of a cone, you would have to remember to add, do you see how a surface area is obviously all of the sides added together? A cone has two sides. So the formula only includes the curved side. You'd have to remember to add the circle yourself, the base, but obviously that's also on the formula sheet, technically the circle. Area of a circle is on the formula sheet separately. But you'd have to remember to put those together. They will give you the volume of anything that's not a prism. So obviously, in this case, a cone. They'll give you the volume of a sphere. They'll give you, I would imagine, the volume of a pyramid, but I've not really seen that come up, to be fair. They will give you the surface area of a sphere, because it's not a prism. A pyramid, you could work out the surface area yourself, right? A pyramid, because it's just different, like it's just triangles and maybe a square or a rectangle. So that they won't give you the formula for. So it's only things, as you said, like cones and spheres, that they will give you the formulas for. They do give you the formula for the volume of a prism, but obviously a prism is a very general term, isn't it? That includes multiple different shapes. Cube, cuboid, triangular prism, any kind of prism really, cylinder. They give you the vague formula for that. They don't give you the surface area formulas, because technically it's just different shapes added together, isn't it? So you know how to work out the area of a rectangle, the area of a circle, triangle, that kind of thing. The other thing with Edexcel, this is sometimes with AQA, sometimes not, but with Edexcel, they use a lot of hemispheres. Like, that was horrible, but like half of a sphere, but they will give you the formula for a whole sphere. So you have to remember, if in that question, you'd have to remember to half the formula, but also, let's say for the surface area, they will give you the surface area of the whole sphere. Well, imagine the surface area of a hemisphere. You obviously have this bit, the curved bit, which is half of a whole sphere, but also, same with the cone. You'd have to remember to add on the second side, which is just a circle, isn't it? You'd have to remember to add that on. They wouldn't include that in the formula. You'd kind of have to put 2 and 2 together in your head. So yeah, cones, spheres, they'll put the formulas that are relevant in the actual question. That's why I knew that I would use both of these formulas, because they won't give you anything that's not kind of relevant. They've only given me a volume of a cone and then the curved surface area of the cone. So I used both of those. So I think that answers your question. So the volume of the cone, in this particular case, this angle here, when it's flat, is technically the whole way round. So it's not the same angle really as it is. Do you know what I mean? The angle, in terms of the cone, the angle's not relevant at all. So that's why we kind of had to go through all these steps to work out effectively, I guess, yeah, the curved surface area, and then relate it over here to get the angle back. Because imagine you literally got that piece of paper, imagine you had that sector, and you were to literally kind of glue it together along this kind of green line. That's where they glued it, wasn't it? They brought A and B together, glued it. That angle is no longer flat, so it's not really an angle to measure anymore. I guess it becomes 360 degrees, isn't it, around the top of the cone? Like, it's that bit there, isn't it? It's the same as this angle. So it's not really, I don't know, the angle's just not relevant in terms of the cone, because the volume was of the whole cone. The cone was complete, wasn't it? It wasn't a section of a cone, it was the whole cone. So I don't know if that answers your question, but we had to use the volume of the cone as a whole, because it is the whole cone, that is the whole volume, to find the radius, and then from there find a way to link the two, which was through the surface area. So they don't really give you general surface area formulas. You'd have to figure, because I mean, surface area is pretty straightforward. It's just area, but multiple. Oh, well, it got really small. It's just multiple times, multiple shapes, isn't it? And then you add them together. So like, if it was a cuboid, you don't need a formula for that, do you? Because technically, you just add all the sides together. That's just rectangles, isn't it? For example, a cube is just squares added together. A cylinder is the two circles, which technically circles are on your formula sheet, and then the curved bit, if you were to lay it, like, imagine a tin of beans or something, if you were to take off the label and if you lay it flat, that's just a rectangle, isn't it? Now, the only thing you need to know is that this side is the circumference. So you might do pi times diameter or 2 pi r. So you just work out the circumference, which I think the circumference is also on your formula sheet. And then this side is obviously then the height. So it's not really too complicated to work out. They won't give you the surface area of those ones because you could figure them out. Do you know what I mean? Like, then that's not too complicated. But a cone and a sphere, things like that, they will give you those formulas, because obviously those are not prisms. Okay. Okay, does anyone have any other questions? Anything else they wanted to go through? Any other topics or a specific past paper question maybe? Let me know in the chat if there's anything else you would like to look at. We also have a past paper live that I'll be doing at 7 o'clock. So you can always come back at 7, and we'll be going through the June 2018. Yeah, June 2018, obviously paper 1, because your paper 1 is this week. So we'll be going through that past paper if you want to sit and go through that as well. That will be at 7 o'clock, not in this live, but in a different one. Right, inequalities. Do you mean like solving quadratic inequalities? That looks like a quadratic to me. I'll get one and I'll paste one on and you can tell me if that's what you mean or if it's something else. Hold on. Okay, copy. Do you mean like maybe something like this? We have to solve it. It's a quadratic. It's obviously an inequality. And you have to solve it. I don't know if that's what you mean. Or do you mean something else? Yeah. Okay, so this is what I'd call solving quadratic inequalities. So you solve them initially in the same way that you would solve just an equation, obviously a quadratic equation, right? So you can always imagine for now that it's, don't worry about the inequality until the end. Just put it equal to 0, for example. You can imagine it's like that. The way that you would solve this, I mean, there's technically 3 ways, but normally the main way is that you want to factorize. You can also do it different ways. This was a paper 3 calculator question. So if you don't want to factorize, you can obviously use the quadratic formula. That's fine. Technically, you can complete the square. I don't know why you would, but you could also complete the square to solve it. Either way, one of those 3 things. Factorize, quadratic formula, complete the square. However you like to solve quadratics. Normally you can factorize them though because of the type of question it is. So I would go into factorizing. Obviously that would be double brackets. Oh, congratulations to the person who's finished their IGCSE. I don't do AS level classes. I'm sorry, I only do GCSE, but I hope your IGCSE went really well. Okay, so factorizing it, obviously 2x and x. First of all, we're multiplying to make a negative answer. Luckily it's 2, so that's also a prime number, so I know it's going to be 1 and 2, or 2 and 1 depending, but it's a negative. So plus and a minus, how do I multiply those? How do I add them to make 3? Probably the 2 here, I guess. 2 times 2 is obviously 4x, plus 4x minus 1x. Yep, that would work, wouldn't it? So factorize it, then you solve it, when you just change the symbol, and obviously that would be positive a half, or minus 2. Now, even if you just get this far, right, this is already 2 out of 3 marks. This is already 2 out of 3, so you've not even had to consider the inequality at all. It's literally just solving a quadratic. So that's 2 out of 3 marks. Now that we're at the end, obviously we want to put the inequality symbols back in. So for quadratic inequalities, there's only 2 possible formats for your answer. So that's quite good. It's only 2 possible formats. Now, if you weren't sure and you forgot when you're in the exam, I would just guess and pick one of those, write one of the 2 answers down and then hope for the best. But obviously, ideally, we'd remember. Now, it depends which way the symbol faces, right? Do you see how in this case, it's facing the quadratic, not the 0. It's facing away from the 0. It is facing the quadratic. So when it faces the quadratic, you have 2 inequality answers. Now, this one's a bit harder because you have to remember also which way round the numbers go. So when it faces the quadratic, you put x, it has to be less than the smallest number. Now, obviously I know there's a half and a 2, but technically -2 is the smaller number, isn't it? So don't get those mixed up. So it has to be less than the smallest number. It also then separately has to be greater than the bigger number. So you have to remember that. That would be your answer for this one. That would be your final mark, because it faces the quadratic. If you can just memorize that, 2 separate answers if it faces the quadratic, 2 separate inequalities, x is less than the smaller number, x is greater than the bigger number. Now based on that, I'll just show you the other format, right? That's the one format. The other format, let's say, just for example, I'll use the same quadratic, but let's say that it was like this. You see how it now faces a 0? Obviously, you still, solve it the exact same way, factorize it, whatever. Get your 2 answers. When it faces 0, it's a range. That's kind of an easier answer, isn't it? So x is in the middle. Obviously, then you put the smaller number on the left, right, and the bigger number over here. X is between the 2 answers. So that's your 2 possible answers. Either 2 separate inequalities like this one, but you have to remember which way around the numbers go. That's the kind of thing that's harder, I guess. Or a range. Now let's say if you were in the exam, you'd solved it, but you'd forgotten which way round it is. You'd forgotten if it faces 0, it faces the quadratic. You forgot that. Just write one of these. Probably the range is easier, and just hope for the best. You've got a 50-50 chance, haven't you? Yeah, so let's say if they also, I think this is what you mean. Do you mean if they had like an equal symbol as well? Oh, that was really bad. Let me draw it again. If it also had the equal symbol, like here and here. If it had that, it's just the equal symbol kind of doesn't really make any difference. It still depends which way it faces, but then you would just copy, like for example, if it did say equal, I would just do that. You see what I mean? Like just copy. So it doesn't really affect which way round you're facing the answer, right? The answer is just depending on which way round the inequality faces originally. If it has also got the equal part, you just also put the equal part. Just stick it on, basically. I think most examples don't have the equal part, to be fair, but yeah, if it does, just stick it on. But that doesn't affect your answer in terms of the direction of the inequalities, if that makes sense. That doesn't affect it. It's just an extra kind of thing to stick on at the end. But I think from what I've seen, most of them, I think they normally maybe put the equal symbol on like a linear one, where it's just a straight, like, it's not an x squared. But you just copy. If it's got an equal symbol, just copy the equal symbol in terms of just stick it under your answer. Yeah. But yeah, those are your 2 possible formats. So you just have to memorize that. If it faces a quadratic, 2 separate answers, but specifically x is less than the smaller number, x is greater than the big number. And then if it faces the 0, then x is between them. It's a range. So that's quite nice. I think it's first of all, you can get 2 out of 3 marks for just solving it, which I'd hope would be fine anyway. But then the 3rd mark is just for sticking in the correct kind of format. If you memorize the format, then it's quite easy. That's kind of it. I mean, I don't know if you want to do another different type of question, but on the same thing, or if you feel like that answered your question. So obviously this was a more straightforward one. They literally just said, solve this. Like, it wasn't more complicated than that in that sense. It just said, solve it, didn't it? Oh yeah, finding the turning points. Some of these topics I also have my own videos on anyway, so also like you can also have a look through my channel and see what I've got a video on this one, for example. I've got a video on turning points, but we can have a look. So completing the square, I'm guessing you mean where there's probably a number in front of the quadratic. That's, I guess, the harder ones. So let me have a look. Oh, this is, I think, is probably the hardest one I've found in the past paper questions. This one here. This one. 4 marks. Yeah, I think this is probably going to cover what you mean, because not only is it 3x squared, it's also a negative. Yeah, you can send them to me on email if you've got questions specifically that you, or if you know which paper it is, I can also have a look. I can look it up. So yeah, exactly. This one is harder. Obviously, the first thing is find the coordinates of the turning point of the curve. Obviously, it's a quadratic. we need to know that we're completing the square. Like, you have to know that that's the context, isn't it? Completing the square. What I would probably do in this one is, first of all, I'm just going to rewrite it because I don't like the... Like, I like to have my x squared at the start, but just don't forget it is a negative x squared, isn't it? So I'm just going to rewrite it so I can look at it as, you know, normal, as a normal quadratic. That's the format, isn't it? So we need to complete the square. Now, I think people do it differently. So you might have done it differently to how I do it, but what I would do, obviously, is whatever the coefficient of x squared is, if it's not 1, if it's bigger, as in 3 is bigger than 1, you'd factorize it out. Now, some people factorize it out of all 3 terms of the whole quadratic. In this case, you can, because 9 is a multiple of 3. But I normally don't, because half the time the end number doesn't divide by the first number, and I can't be bothered with any decimals or fractions. So I don't normally do that. What I tend to do is factorize it out of just the first 2 terms, which is fine. You can partially factorize things, that's fine. So, I mean, the y is kind of irrelevant, but we'll leave it there for now. So I pull out minus 3. Now, just be careful. Obviously, we're not only just dividing by 3, but we're also dividing by a negative. So this 18x, not only is it obviously going to be 6x, but it will become negative 6x. So just be really careful, because I pulled out the minus 3, didn't I? If I were to expand that again, it would go back to being positive 18, wouldn't it? Plus 9. Okay, just leave the 9 at the end. That we'll deal with that later. You can obviously put it inside the brackets, but I just think there's no point. Okay, now I'm going to complete the square. Right, now that I've got that, I can look inside those brackets. So minus 3 still on the outside. And then this is our format, isn't it? We do x, you copy the symbol, which is now a minus, and then you half that term, don't you? So that would be 3. Then that is squared, isn't it? And then on the outside of that, you always subtract whatever this term is squared. Now, it doesn't matter if it's positive or negative, because when I square it, it will become positive anyway, won't it? So that doesn't really matter. But you always subtract it. So that's, I'll just write it out. Normally I just work it out, but I'll just write it fully. Again, don't forget the 9 is still kind of floating at the end. Okay, so this bit here, I'm just going to work out before I expand. I probably would have just written it straight, but just to kind of show you where these numbers are coming from, because there's quite a few of the same number, 3 and 3, 9, 9. It's kind of confusing. So that minus 3 squared becomes positive 9, but I'm subtracting it. So you see how it's still a negative, isn't it? I'm still subtracting that 9. Now I'm going to expand it. What I mean by that is just multiply by minus 3. Both of those. So obviously I'm not going to expand the literal squared brackets, because that would be going backwards, but I'm just going to write minus 3 on the outside of that. Do you see? That's what I mean by expanding it. But then you also have to remember to multiply the minus 3 by this minus 9. So that becomes positive. Be really careful of the symbols. 27. Now I can worry about the other 9. Now I can deal with that, can't I? The last step is just to add them. The reason why I didn't put it inside the brackets is because then I would just be dividing it to put it inside and then multiplying it to put it outside again. So it kind of seems counterintuitive, really. That's just my personal opinion. That would add up to, that makes 36, I think. Yeah. So I've completed the square. Now, the last thing, because I think that was probably the three marks. Let me have a look at the mark scheme. Yeah, this gives you the 3 marks, right? The final mark is just for the turning point coordinates. So, let me get my highlighter. Don't worry about the minus 3 on the outside, because that has already technically had its effect back here, didn't it? We already had that effect. So don't worry about the minus 3 on the outside. That makes no difference to my turning point coordinates. This one here, inside the bracket, is always the x-axis or the x-coordinate. But the only thing you have to remember is that it does change the symbol, doesn't it? So you see how that says minus 3? I'm actually going to put positive 3. So just remember that, symbol change. And then this one, on the outside, at the end, that is the y-coordinate. Now that one you don't change the symbol. So if it says positive 36, you take positive 36. If it says negative 36, you take negative. Oh, only one coordinate, not 2. 36. 336. So the last bit's really easy. It's just the fact that, you know, that obviously the main question was the completing the square, wasn't it? So that was not only having an actual coefficient to x squared being 3, but also a negative as well. You have to be really careful with all those negatives, positives, you know, double negatives, all that kind of thing. But it is still the same method. I mean, yeah. So yeah, that's probably one of the hardest ones I've seen, because of the fact that it's both. It's got a coefficient that's bigger than 1 and it was negative. That's probably the hardest I've seen. Yeah. Yeah, it's these last final, if you're looking at a grade 9, it's these kind of final details, isn't it? The really kind of harder questions that they could throw at you. It's this kind of extra detail here that will make the difference, isn't it? Yeah. Yeah, that's the hardest one I found. I don't know if 2024 was harder, but I haven't seen that paper, so apart from that, that's probably the hardest one I've seen. But yeah, completing the square I think is a good one to know because it will always come up. Whether it comes up with, you know, this level of difficulty or not, doesn't matter. I don't know, but that's the hardest it could be. So hopefully anything else will be easier. Yeah, I'm just having a look at your questions now, okay? Let me have a look. Oh, yeah, another cone and sphere one, yeah. What's that? Make T the subject of the formula. And congruent one. Okay. Do you know what paper this was from? I don't think I've seen this one. Maybe this was the 2024 one. Just because then I can, if I have the paper, I'll copy like a blank version of it. But if not, then I can copy your picture. Yeah, they just put it together. Yeah, I was thinking. Okay, I'll just see if I can copy the image. Can it let me? No. Okay, hold on. Let me just download them and then I'll see if I can upload it. Just because for the shapes ones particularly, we do need to be able to see. I'm not going to draw it for myself. Okay, just give me a second to upload it. Okay, what was this one? Yeah, this is the cone one. Okay, let's see. So what have we got? Again, you can see that they've given you the relevant formulas, right? The only thing to consider, as I said, is that they've given you a whole sphere here, and this looks to be, yeah, a hemisphere. So that's the only thing to consider. Edexcel, they will tell you the whole sphere. You have to remember to half it. So a solid shape S is made from a hemisphere and a cone. So they've stuck basically half of a sphere on top of a cone. The radius of the hemisphere is equal to the radius of the base of the cone. Yeah, that makes sense because they're matching. The radius of the base of the cone to the height of the cone is 1 to 3. So that's, yeah, they've kind of shown you there. That's relating to the formula for the volume. The volume of the whole thing is 360 pi. I'm assuming, was this non-calculator? That's all right, don't worry. I was assuming this was non-calculator because they've given it in pi. I don't know if this is calculator or not, just so I know what I can and can't use. I'm assuming it's non-calculator by the look of it. Move this over and then we can write over here. I think the first thing I would do is create an equation for this. What was it? Oh, what were they asking for? Work out the height of, oh, the height of the whole thing. Okay, that's fine. So obviously I'm going to set up the volume of the whole thing, right? Actually, I think in my predicted paper I made one similar to this. It didn't have a ratio, but it was kind of similar actually. Oh, it was calculator. Okay, nice. Okay, so I'm going to set up the equation for the volume of the whole thing. So the volume of the whole thing would obviously be the cone. I'm going to do the cone first because it's a bit easier. Pi, nope, a third pi r squared h. I'm just writing it like this and then we'll put the numbers in afterwards. Plus the hemisphere, which is the sphere. So that's a 4/3 pi r cubed. But remember, I do need to divide that by 2 because it is the hemisphere, isn't it? I don't know if you can see all of that. Maybe I'll move it over again. There. Now that is the volume. So then now I can input what I know. So we don't know, we don't know the radius, right? We just know that they are the same. We don't know the radius or the height. That's fine. So I'm going to use my ratio. What I would probably do, because I've only got, only got one equation here. Like there's only information enough for one single equation, the volume of the whole thing. That's my only equation. So I only want to have one letter. You can only solve something if it's got one letter. If you've got two letters, you would need simultaneous equations. You would need two equations, wouldn't you? So that's why I'm thinking, see how we've got radius and height. That's two things. Obviously the volume is a number. I will sub that in. So that's, ignore that letter. So that's why I'm going to use this ratio. I want to put everything in terms of one letter. Now you could use the radius as r, you could use like x or whatever you want to use. But probably what I would do is, because they've given us kind of a relationship between the radius and the height. Let's say, for example, if I put, maybe if I use a different color so you can see it. Let's say if I put x as the radius, right? Let me call x the radius. Do you see how the height of the cone would be 3x? But that's the same letter, isn't it? Or you could use r and 3r, whatever letter you want to use, it doesn't really matter. That's probably what I would do personally. I think you could probably do it differently, but that's what I would do. So I would sub that in then. So I've got a third pi. Now the radius squared, so x squared times by the height, which I'm now classing as 3x. And then plus the other thing, 4/3 pi x cubed over 2. And then also, obviously, I'm going to put equal, not v for the volume, but the volume is actually 360 pi, isn't it? So I'm going to sub that in as well. Do you see how now I've got an equation with just one letter? That's what I want, isn't it? I only want one letter. I can only deal with one letter because I've only got one equation. So that's what I'm doing. Now all I need to do, what were they asking for the height? I probably need to find the radius and things like that. So I'm going to solve it for x, because what else am I going to do? There's only x here, isn't there? Now the first thing you could do if you want is knock off all the pi's, as in if you divide by pi, it would cancel out because all of them have pi. All three terms have pi. So I'll probably just get rid of that initially. This first one, we've got 3 times a third. What is a third of 3? 1. Basically, so that cancels. That would just be x cubed, wouldn't it? That first bit there would become x cubed. Predicted topics. Yeah, so Fatima, I actually have a predicted paper that uploaded today in the morning. It uploaded on my channel. And the actual paper is linked in the description as well if you want to look at my paper and my answers. And my predicted topics, or at least I went through for Edexcel, this is for Edexcel, yeah. I went through all of the past papers for paper 1, and I just had a look at which topics came up the most frequently. That list is, where is that list? I think I have a video called Most Common Edexcel Non-Calculator Questions. It's probably linked in the description here, actually. Maybe I might have linked it. That one, if you just start that video and just look at like the intro, I've got a list of, it's quite a few to be fair, obviously it covers the 20 odd questions. But yeah, if you want to look for some predicted ones, I've got a predicted paper and I have kind of a list of what I saw came up the most on that other video. So they're the most recent videos in my channel. If you have a look at my, not live, but an actual video, if you have a look there, that might help. But I definitely think cones and spheres tend to come up quite a lot, personally. Okay, so that's that first bit. This bit, the way I think we've got 4/3 divided by 2. When you've got effectively two fractions, we're dividing twice, you multiply the denominators, so like 3 and 2. So that'd be 4 out of 6, which is 2/3, right? That would cancel to 2/3 x cubed. Okay, and then we've got 360. Now these are both x cubed, so I'd want to add those together. That's obviously 1, isn't it? Or 3/3. So what's that? 5/3. Again, you might rearrange it in a different order to me. That's fine, as long as you get the same answer. You said it was calculator, right? So I'm just going to... I mean, you probably could do this without a calculator, but... 360 divided by 5/3 gives me... Oh, yeah, this is looking... I'm pretty sure this is a cube number. 216. And then we'll cube root it. Maybe this was non-calculator. I know they said 2 was calculator. Maybe it was actually non-calculator, because I could have done this... Probably could have done this yourself. Yeah, so I've got x is 6. Now just don't forget, what was x? X was the radius, wasn't it? So I now know that my radius for both is 6. What was this? I'm assuming centimeters. Yeah, centimeters. Now, come back to actually what were they actually asking me? So they were asking for the height of S, so the whole thing. Okay, well, that means the height of the hemisphere and the height of the cone. Now, first of all, the height of the cone is 3x, isn't it? So I could work that out straight away, couldn't I? Height of the cone would be 3 times 6, wouldn't it? 18. And then if you think about it, I know you've kind of drawn on it, but if I get a different colour so you can see it. from the center of the hemisphere vertically up, not there, but like the center, roughly here, that's a radius, isn't it? Vertically. So you see how the radius would the height of the whole thing is a radius plus the height of the cone, isn't it? So the height of the whole thing, if I scroll down, the height of the whole thing would be those two added together, wouldn't it? So I don't know if you have the answer, but I would have given the answer as 24. That would have been what I would have put for the answer. So it was really just setting up an equation, but also realizing that we could only have one letter. So I needed to use that ratio to create, you know, two versions of using the same letter for the height and for the radius. So that's what I would have got, 24. That would have been my answer. But yeah, that's what I would do for that one. I don't know if that makes sense. Yeah. Okay. Perfect. Right. The next one, I think you had. What's this? Oh yeah, this is our congruent. It's always congruent triangles that are the hard one, I think. Let's see. So we've got A, B, C, D is a square. A, B, E, I think that says A, B. Oh yeah, this one here is an equilateral triangle, so all of these sides are the same. So prove that triangles ADE, where's that? This side, and B, okay, so the left side and the right side are congruent. So congruent triangles, yeah, you've written the topic, right? It's got to be some kind of side, side angle, side maybe, angle, side, angle. I think you can also do angle, angle, side, I think. Yeah, I think there's like four. Obviously there's a right angle one as well, but doesn't look like there's a right angle here. So we want one of those. So we need to prove that three things are the same. Now, it looks like they've ticked one of yours. Yeah. You said DA is equal to CB. Yes. So that's your first one. I would have said that as well. Because they told us it's a square, given that information, the sides of the square are the same. So yes, I would have said this bit. All DA is equal to CB because all sides of a square are equal. That would make sense, wouldn't it? So that's one thing. We now need two more, don't we? We need two more things to kind of make up one of these. What else have you? I'm just seeing what else you've written. All sides. Oh, I think you were close here. Like your reason is correct, but you just chose the wrong sides. So the equilateral triangle sides is this one and this one, isn't it? In terms of the other two triangles. The top two, we don't know technically, do we? So this would have been fine if you'd have said A is equal to B. I think they've written that down there actually, haven't they? And then because of that reason, all the sides are equal on an equilateral triangle, then you would have got that. So that's two things. So currently we've got two sides, haven't we? So we could maybe go side, side, side or side, angle, side. I think I would probably go with this one. What I'm thinking, right, based on the equilateral triangle, think about angles now. We know that those two angles are the same. I know that's not inside the other triangles, but those two are the same, aren't they? They're both 60. And then think about the square. So put kind of all that information together. I'm going to try and use a different colour. We know that that's 90, don't we? So my logic would be, if I know the whole angle's 90 on both, and then I know that this part and this part, which is outside of the triangles I want, are both 60, then surely that guarantees, need a different colour, I guess that one, that guarantees that this bit, I don't know if you can't see that, can you? I don't know, maybe this one, hopefully you can see that. This bit here, yeah, that's better, isn't it? Would be 30, wouldn't it? It would have to be, and then this one would also be 30. So therefore, inside the triangles, those are the same. That's probably what I would say for my last reason. Maybe there's different ways to do it, but that's probably what I would say. So that one's a bit harder to explain, isn't it? There's kind of multiple steps. So we've got two sides currently. This one and this one. We're saying two sides are the same, right? That's two things. And the sides are next to each other, so that's good. So that's why I was kind of also focusing on the angle between the two sides. So how would I write that? Let me move this over a bit. How would I write that? So I'd probably write DAB, as in an angle, is equal to CBA, because they're both 90. You could write, because the angles in it, what was it, square angles in a square are obviously 90, something like that. And then you could also write, what was it, EAB is equal to EBA, which is specifically 60 because of angles in a like an equilateral triangle, right? And then you could say, well, therefore, in my actual triangles that they actually want me to ask about, not that one, DAE is equal to CBE. You could leave it like that, or you could write, well, technically we know they're both 30, don't we? We actually know that because of those two reasons. So this one was, sometimes one of the explanations is a bit longer than the others. So angles in square, and then this one, angles in, not a triangle, but specifically equilateral triangle. And therefore that would mean that the ones inside the actual triangles that you're looking for are the same. So I would have said those three things. So the two things that you said, but just correct the sides on that one. Therefore congruent because of, I would have said side angle side. That's what I would have gone with. I don't know if there's different ways. I mean, sometimes there's multiple different ways, but that's what I initially first saw. I don't know what your teacher has put. They put that, and then number 3, D8. Oh, okay, yeah, they've gone with the same as, they just didn't finish the working. They've gone with the same as what I said. Yeah. Or I don't know if that's your correction there, actually, in the green, or if that's your teacher's correction. But anyway, that's the third explanation, basically. So you're basically halfway there. As long as you got those two right, you would have had 2 out of 3 marks. Well, I don't know, well, it depends. I guess you get 1 mark for the last final bit, so maybe 1 out of 3 marks. But either way, you almost had 2 of the 3, reasons at least. And there's that last one. That's probably what I would have done for the last one. Yeah, I think congruent ones are quite hard, to be honest. Yeah. So that's that one. And then your other one, the other one I think was just rearranging by the looks of it. Rearranging. I'm assuming it was this question 11, right? Not the one below. I'm assuming it was question 11. So we've got make t the subject of the formula. So I might write this over here actually, just so I can write below it. U is equal to 4 plus root 5t in the square root. Oh, you were close. Yeah. Yeah, what I would have done... Oh, hang on. Let me go back. Yeah. Yeah, it's quite a tricky one because I'm using like multiple different reasons for one angle. So that's why I try to use different colours. So there's the 2 reasons basically. The orange is this bit here, isn't it? The orange is that because they told us it was a square originally, they told us it was a square. So I know that the whole of that side, well, these 2 sides here, the angle between them is obviously 9, technically the same up here, but that's obviously not really relevant. All of the angles in a square, each angle is 90 degrees, isn't it? We know that. So I know that this whole angle, you see this orange one, is the same as this whole angle here, which I know is not necessarily inside your triangles that you're trying to look for, but it kind of overlaps with that triangle, doesn't it? So I said, right, these 2 angles are the same because they're both 90, because angles in a square are obviously all 90. Same with a rectangle if it was a rectangle. That's the first bit. The pink bit is then looking at the equilateral triangle. They told us it was an equilateral triangle, this one here, didn't they? ABE, they called it ABE. Now, if it's an equilateral triangle, not only are all the sides the same, but also all the angles are the same. And if you know about, obviously, triangles add up to 180, don't they? 180 degrees. So obviously, divide that equally by 3. Each angle in any equilateral triangle, even this one up here as well, is technically the same, is 60 degrees, isn't it? Because you have to split the 180 equally between 3 angles. So I know, because it's an equilateral triangle, that this section here and the pink bit are the same angle as each other, aren't they? Because of that, because of angles in an equilateral triangle. And then now this is, because again, I know that's still outside of the triangles we're looking for, isn't it? It's like kind of outside of that. Then I link it to my triangle with the green bit, this kind of pale green bit here. If the whole angle was 90, and then part of it's 60, the other part, which is actually in the triangle I want, isn't it? They said triangle ADE, that's inside the triangle, the green bit, isn't it? Because obviously I'm trying to relate it to inside my triangle. If the whole angle's 90, one part of it's 60, and then the bit that's inside my triangle that I actually want is the only other bit left, do you see how that would make that 30? Obviously 90 minus 60 is 30. I don't think you necessarily have to work out the numbers, but I'm just kind of demonstrating. And then because I also proved that scenario is exactly the same on the other side. So therefore, the green angles are also, they're both 30, and therefore they're both the same as each other. But the reason why I want the green angles is because those are the angles inside the triangles that they want me to prove is congruent. And it works for side angle side, because you said, let me get my highlighter. You said, color, should I use green maybe? You already proved that this one is the same, didn't you? And then technically down here we proved that this one is the same. And then do you see how that's the angle between them? Side angle side. So, and then it's the same for the other side, isn't it? Yeah, the last bit I think is quite hard because you have to kind of go through all these other angles that don't seem that relevant because they're kind of outside of your triangle, but it does then link back to inside the triangle at the end. Just from the information that they've given us, basically, on the square, how does a square work, how does an equilateral triangle work, that kind of thing. But yeah, that bit is quite complicated, I think, that bit there. So yeah, I went with side angle side personally, that's what I did. Oh, where's it gone? Here. Okay, so we're rearranging this. I think you rearranged it like mostly correct, but because of the small mistake you made, I think it made them not be able to give you any marks, which is a shame. So what I normally do when I rearrange things is if I've got something plus or minus, just, do you see how it's kind of just, in my head it's like a low-hanging fruit. I don't know if you know what I mean by that. Just something really easy to pick off and deal with. So what I would like to do, I personally would have moved the 4 first. I would have subtracted the 4, just get it out the way, because yeah, we are going to, I know you've squared, we are going to square everything, aren't we? That's fine. But it's more complicated to square something when you've got like 2 terms in the way. I would rather isolate this bit and then square the whole of the other side, if that makes sense. Like I don't want any other terms on the side with the square root. So then when I square it, it would give me this. Now you don't have to expand it, you can just leave it. You could expand if you want, we don't have to. And then do you see how the last thing is then just, it's just the order that you did it in. Like you did all the correct steps, but because the order you did it in, it just didn't quite turn out. Because, so I think you squared first, didn't you? And then you moved in that case the 16 and then divided by 5. So like you've done the same as me. I squared, I moved, I subtracted a number and I divided by 5. We've done all the same steps. It just didn't work out. I mean, you can do it in the order you did it, but you just have to square it differently, because if I move it down, I'll show you why yours went wrong. Because, so if I start again, if I were to square it first, I'd have to square everything on both sides. So that would obviously be u squared, fine. But do you see how I'd end up with this? Squared. And that to me is just annoying. Like I'd rather not. You can do it that way, it's not wrong. As long as you obviously expand it correctly. But I would rather not deal with that personally. Because it's not that we can just square them all individually, you have to square the whole of the side if you do that. So that's why I like to kind of move the 4, in this case the 4 out of the way first, so that when I do square the side, it's only just both sides fully squared, you know, the whole thing. Yeah, I don't know if that makes sense. It's just, yeah, I would probably recommend moving, if you've got a plus or minus number, I would probably normally always move that first if I can, just get it out of the way and then deal with any kind of, same with square rooting, square or square rooting, I'd probably get that isolated first. That was probably the only reason. But it's annoying because you did do all the same steps that I did, just because the order was different, it didn't come out the same, which is annoying because that's 3 marks, isn't it? So yeah, I just moved the 4 in the first place, and then it was a little bit easier from there. Yeah, perfect. All right, guys. Well, what I'm gonna do, I think, is I will leave the live here because in 20 minutes we're going to go through an actual past paper and a different live. So I'm going to leave it, and I need to set up that live. I need to set up the paper. Standard form and vectors. We can always do that. I'm going to do more of these Q&As, right? So we can always do that another time. When is my next one? Just thinking. I don't know. Well, it depends, because obviously you've got Thursday's your exam. I'll obviously do one on Wednesday. I'll do one on Wednesday. I don't know if you might want one tomorrow or not. Really depends what other exams you've got, doesn't it? But yeah, there will be. Keep an eye out. There will be more. If you want to have a look through the next past paper that we're about to go through, we'll do that at 7 o'clock. It's the June 2018 one. And yeah, definitely have a look at my predicted past paper if you want to use that for revision. That's literally just uploaded this morning, and obviously it's linked in the description if you want to download it. And have a look. Yeah, most repeated non-calculated Edexcel questions. I have a list of topics that I think are the most likely to come up, so that might be helpful as well. But yeah, otherwise, thanks for coming, guys, and I will see you either later or maybe tomorrow.